Alright, another draft physics video presentation. Endeavor to persevere episode. Ugh. Morning after the election. Yeah. Still isn't decided, but it doesn't matter really. Statement has been made. This is a bug planet, and yeah, people are bugs. They're so fucking stupid and corrupt and lying and conniving, and just doesn't make any sense really. I mean, all this neurological capacity to come up with this, no. But anyway, I'll have to work on it. There's a theory behind it all somewhere. I mean, look, it's all about one issue. It's always been about one issue. But I mean, to defend the lying, conniving, stupid corruption of Trump, to endorse it, ooh, how could people do that? I mean, there's not a single good principle anywhere to be found. Nothing. Anyway, shocking, stunning, really. I mean, the first time you're saying, okay, maybe they just didn't know the truth. Maybe they couldn't see right through this piece of tissue paper, and they actually thought it was a human being. But it's all been proven. The incompetence, the stupidity, the corruption, it's all been proven. And they still pull the lever. Amazing. Because the commies are coming. And they're not commies. But anyway, it's just too crazy. That's all. That's just my statement. So, just this context I have to exist in is just getting insufferable, frankly. I would have never predicted this crazy. I mean, could have predicted, it's going to be some problems in the future. But the real problems haven't even really blown up yet. And these are just like, you're expecting bullets and grenades in the war, and they're throwing like dirty toilet paper at you or something. You're like, I didn't expect that. Ugh. Anyway. So, here's another physicist. Okay, Berkeley, head of the physics department. Then he's into quantum computing now. I saw him at another lecture with Leonard Susskind, and the panel basically all agreed that quantum computing will advance nothing. Well, it's going to be completely useless, which is hilarious, right? I mean, he's head of, Berkeley's quantum computing effort, and they're basically conceding that, it's only going to be good for physicists doing abstract bullshit equations on their own quantum physics. It's really not going to do anything for mankind in any way. It'll just help them make more fake pictures of black holes and find some more fake gravitational waves and all that kind of crap, but it's not going to do anything real. Which is just, it was kind of a funny concession. I mean, Susskind really is crazy. I mean, he is loop-de-doo nutty. He thinks space is entangled. I mean, actual space is entangled. I mean, now the nothing is entangled with the nothing. It's just too fucking stupid. So anyway, this is like a highly respected, highly doctorized professional physicist, and he can't get one piece of the slit story right. I mean, just not even a piece of it. So let's play the video and just marvel at this is what's running everything, is this garbage, this made up crap. Everybody's just living on made up crappy stupid fables of how reality works.
For the next few videos, we'll focus on a very simple experiment that demonstrates this.
So, like his manner, like his style, laid back, I'm a scientist, blah, 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 all that kind of crap, but fucking idiot.
Strange behavior of nature at the atomic level.
All right, now what you'll see in here, if you have any experience with Feynman lectures, is he basically is just going to redo Feynman's mistakes. And he's just going to emphasize the mistake part. He's not going to get, the little bits where Feynman was right. He's not going to have those in it. He's just going to glaringly do exactly what Feynman did wrong, and in almost exactly the same words.
This is the double slit experiment that many of you are probably familiar with from high school physics, where two.
Yeah, well, frankly, I wasn't all that familiar. I guess I gave up on physics by the time they got to that. I couldn't get past the silly drawing of a photon, and really, that's when physics left the building for me. And I was just like, well, what? I'm, once you introduce gremlins into the story, or pixies, or fairies, I mean, doesn't your brain just kind of turn off that this story isn't going to be about anything that means anything? And that sort of happened to me. So yeah, I didn't really know what they were saying about this stupid two-slit experiment until much, much later in life. And then I just marveled. I said, what? They actually think it goes through both slits and interferes with... What? What? It can't be that silly. But they are. Ugh.
To illustrate the wave nature of light. Now, the nature...
So again, the nature, the wave, and we know it's not really its nature. I mean, we know it's this tiny little piece of momentum that hits something in this tiny little location. And it's not how waves behave at all. So that's the funny part here is, obviously Feynman wasn't a big fan of this wave nature of light statement. I mean, he overtly stated, you're being taught wrong. It's not a wave. There's something else happening. And, none of you paid any attention to that.
Of light was a source of great confusion for physicists over the centuries. Newton believed that light was a rain of particles.
Yeah, the rays, little stuff flying in straight lines. That's exactly what it looks like. It behaves like, it seems like, it fits like, it makes sense like. It's doing exactly what, gravity's doing the same thing the light bulb is doing. And it all looks like it's got to be rays. Gots to be.
Which he called corpuscles. Later there was...
Feynman called them clumps. So, there's plenty of evidence that this isn't what their own physics believed. Again, Feynman called them clumps. You don't call a wave a clump.
A lot of evidence that light actually travels as waves. But
so there isn't a lot of evidence. There's like zero real evidence that it does any of that. I mean, it doesn't do what a single slit in water does. It doesn't, it really doesn't. The fucking facts don't match. So they just keep saying it, and, the real facts don't indicate it at all.
in the beginning of the 20th century, Einstein discovered the photoelectric effect.
Well, I don't think he discovered it, but whatever. Continue. He interpreted it. He gave you a cause, and he demonstrated that the cause is inconsistent with whatever gradual on and gradual off, and something other than discrete clumps of energy.
Which showed that light is transmitted as in discrete packets, which we now call photons.
Well, no, you call them wave packets. So again, this idea of what a photon is, I'll draw it again. I mean, it's just, I didn't realize that this is what the argument's really about, is that people can't understand that there's not just two possible ways to draw it. Just like there's not only two things in the world, greedy, unearned capitalist inheritance lovers and communists. Those aren't the only two philosophies that exist. So to the drawing board and such. So we'll pause and I'll be back. Alright, I should be back. So, we know that a photon we discovered, okay? I mean, I don't know if Newton exactly had done it or, Hertz and all these other people, they all played with this idea of what the hell this energy is and trying to detect it. And, first it was just light, and then it was, this other varieties of light. There's colors inside of the light. Newton knew that much. There's something that differentiated it, and you could understand that, well, maybe the differentiation goes this way and it goes that way, and this explains other kinds of radiation. So then they ended up with this electromagnetic spectrum, which really doesn't have anything to do with electromagnet. But anyway, a spectrum of how this stuff comes, and it comes with this key element called the frequency. Now, what does that word mean to people? I mean, they think that something is a little blob, a packet of frequency. I mean, it doesn't make much sense. I mean, a frequency is something that's time dependent, okay? I mean, it's just completely the same thing as time. And you're just saying that it's something that has to happen over a period of time. And the something is that it has to say something like on, off, on, off, on, off. It has to be a signal. So why would anyone think this was a whole photon? That this thing could say, I'm 500 nanometers. I mean, that doesn't make any sense. I mean, it really doesn't make any sense. I mean, it's just, why would you do that? So they know when they draw waves, they always draw them with a bunch of waves coming at a frequency. And even this doesn't make any sense because, even in their own two-slit analysis, they're drawing these vectors from, these locations that are completely wrong. But anyway, and they're just comparing the length and saying these two meet at the same time. Well, they can't meet at the same time. How would that make it a photon? That doesn't mean anything. I mean, a clump and clump at the same time doesn't mean anything. I mean, that doesn't say what your clump is. That doesn't tell you anything about this 500 meter thing, nanometer thing. It doesn't tell you anything about distance or time or how the photon is received over a period of time. I mean, you just can't, frankly, can't make any sense out of this. Oh, sorry, I drew that kind of too low. So, I mean, it's so fundamental to what's happening is that this frequency part. So I mean, how can you think of it as something other than, it's clumps, okay, it's discrete bits of the same stuff, and there's a frequency, a time between them in space, and that's a photon. Of course, it gets a little more complicated because the photon has a polarization, as I've pointed out repeatedly. And so the photon, obviously these clumps aren't exactly in the same place in space. And that explains what the polarization is. But I mean, no one ever uses any alternative explanation model or a comparison or anything. They never compare it to this, okay? This model of a photon. They always say, there, that's a photon. Somehow this is 500 nanometers. It's just, 500, it's just a clump of 500 nanometers. I mean, just, like I said, even their own wave theory, they're basically saying it's a clump of waves that are 500 nanometers somehow. But it arrives, instantaneously and says, I'm a clump of 500 nanometer waves or something. It just doesn't make any sense. That the rational description, the one I think Newton would say, hey, yes, that fits, is never considered as part of the conversation. It just isn't allowed to be the competing theory.
No, there was a similar kind of confusion about electrons.
All right, now this is where it all goes sideways and they just start lying. I mean, they just start pretending. Actually, he says it correctly, so I should give him credit because at least he's not completely dishonest in this part of his statement. So let's play the statement, and so I can show how it's not completely dishonest. More volume.
Which were first believed to be particles, but then there was evidence that they behave like waves in phenomena such as electron diffraction.
Right. So electron diffraction means that it's nothing to do with a two-slit experiment. So this is all based on the fact that they had an electron experiment where you could you scattered electrons off of a surface. I forgot. Should pause for this part of the interaction, but whatever. We'll just go for it. So, instead of doing it, it's not a two-slit experiment or anything like it. So they ended up with a material that ended up being very consistent in the sense that it's a crystal with lots of layers in it. And they shot electrons at this substance. So first they were just shooting it at nickel, and they ended up, having an oxide on the nickel, so they had to heat it. And when they heated it, they created this crystal surface. And what they found is that the electron scatters here, or it scatters here, or it scatters here. It scatters more at these locations, and then it has a preference for like 43 degrees or something. Like it scatters most there. So it's sort of like an interference pattern in the sense that it's a little clumpy. But it's not really mathematically anything like that. It doesn't have the same mathematics or anything like that. And the truth of it is that, well, quite obviously what the electrons are doing is they're hitting different layers and scattering off the different layers. And you could understand that they could scatter twice or they could scatter 3 times, that there's certain possibilities between each layer, and that once you go into a layer you have to get out of the layer, and that's what's creating places where it's more likely for you to be, is the fact that you can't get in or out without some possibility of hitting another electron. I mean, it's basically electrons hitting electrons. That's what they're bouncing off of to create the scatter. And so they call this a two-slit experiment. I mean, it's not the two-slit experiment in any way. It's just not. The same principles aren't involved, and you can understand why they're not involved. I mean, it's a completely different kind of experiment. And so they say because that happens, they're thinking it's waves, when clearly you could just understand that I can understand doing that one with basketballs or baseballs. If I created a matrix that I had to throw the basketball into, and that there would be certain outcomes that were going to be more likely than other outcomes in terms of how the ball's going to bounce. Duh.
And so there was a growing confusion about the nature of atomic particles. Were they wave-like or particle-like? And this confusion did not get resolved until the mid-20s, when the laws of quantum mechanics were discovered, which actually showed that atomic particles are neither waves nor particles.
They didn't discover anything. They just realized, okay, there's a probability. And then they decided to say probability is some sort of, the mathematical probability means it's a real mathematical thing in space, that somehow math is reality. And so we don't have to explain now the outcome. We'll just say magic did it. But I mean, it's no different than you going to Las Vegas and saying magic decides where the ball goes on the roulette wheel, and magic decides how the dice tumble. Magic decides when you spin a wheel. I mean, it's not magic's deciding. There's not some random god deciding what number it lands on. There's real physical circumstances, and there's real physical circumstances in all these experiments that are actually causing the effect. There is no magic. So in the 20s they decided magic's a realistic possibility as a winning answer. And it's probably in the context of Einstein getting away with bent space as an explanation for gravity. So they already opened the door wide open to vacuous, empty explanations, and so they were all comfortable with vacuous, empty explanations.
Particles, they behave in their own strange quantum mechanical way.
Right. So that's almost a direct quote out of the Feynman lecture.
And it's this strange, counterintuitive.
Alright, so there's nothing counterintuitive unless you are doing things like, what's counterintuitive to say something, that this piece of chalk has a frequency. That's counterintuitive. That's just fucking silly. Yeah. And it's silly to think that a photon is some clump that has a frequency label on it. That it's not made of a frequency. That is an event that takes place over time.
Quantum mechanical behavior of atomic particles that we'll try to describe through the double slit experiment.
Yeah, well, so he's going to try to make something irrational rational. So he's going to take some kind of silly story and say, this is why the silly story is right. And he can only do it by completely pretending the evidence is something completely different than what it is. I mean, he's not going to show you the facts and say, this is how the facts add up. He's going to draw you a fantasy and then explain how the fantasy works. Well, yeah, okay. It's not the truth, though.
Now, this experiment really illustrates many of the features of quantum mechanics. And
it illustrates how gullible and foolish and stupid human beings can be, how easily fooled they are. You don't have to trick them with anything very elaborate. They're suckers. They want to believe. They'll make it work. They'll force it. It's just showing that, you know, we're just chimpanzees and we're still smashing our favorite little square peg into our hated little round hole, and we're just going to keep doing that apparently. Fuck.
Since it does so in a very simple context, many of you...
Yeah, it's a very simple experiment that you've completely distorted and perverted into nonsense because you can't understand what your own physics, you know, and really the mistakes are so glaring.
Will find this intuition to be very useful as we go along. So many times in the future we'll be able to point back and say,
yes, this is where we left the road. This is where we had one drink too many. This is where it all became just a sad, pitiful adventure that we're going to now rationalize. You're going to live with this mistake, and you're just going to force the mistake to be a reality, and you're going to contrive a whole big pile of lies to make up for this accepted lie.
Remember this double slit experiment? It's just like that.
So that's another line right out of Feynman.
On the other hand, some of you might find this intuition not very useful because you might feel that it takes too many strides.
It takes too many strides. Yes, it's too liberal with the truth. It just totally doesn't pay any attention to the actual facts and the actual pattern and the actual geometry and the actual mathematics and the actual measurements and the actual factual thing that actually factually happens. It pays no attention to reality.
Some of you might find it difficult to relate to the double slit experiment, and
yes, I can't relate to a silly story completely made up and you don't have a single fact to defend it. You're going to tell me extraordinary bullshit about how particles go through two slits and then interfere with each other when your own physics says this ain't what they do. Okay, there just isn't any evidence that these forces ever interact with forces, and why am I saying they do in this special little stupid circumstance? And then you invent silly principles that have nothing to do with the reality. Oh, it's because you can't confine a photon and it gets all upset because you're going to know where it is. I mean, what?
Some of you, especially with a computer science background, might prefer the very simple description of quantum bits that we'll start with in the next lecture.
Right, so this is almost funny, right? It's calling quantum bits qubits. Like quantum computing has something to do with reality.
That's going to be entirely self-contained, so if you have trouble following the intuition from this lecture, don't worry, we'll get to qubits soon.
Right, so he's talking about a conflict between people who are thinking in terms of the qubit reality not being able to accept fantasies. Yeah, when it's just like, oh, come on, they're the silly people who think your little bits of quantum crap can jump to the future and find out what the right answer is because they're entangled with it. Ugh.
Okay, so let's start with the double slit experiment. So in this experiment,
So he's even metaphoring it in the 1960 mode that Feynman was describing, where he's not even doing this on photographic film. He's got a bucket to catch the photons that he's moving back and forth. I mean, it's just so archaic. But again, and drawn in preposterous proportions that just emphasize how the logic is so flawed. I mean, why make the double slits? Why have this huge separation? Why not acknowledge that this target is far, far away and that any diffraction in the light is going to be magnified with distance, and that some things aren't going to be magnified with distance? The fact that the slits are less than a millimeter apart, isn't going to be magnified with distance.
we have a source of either light or electrons. So
again, they keep saying that they've done this experiment, either light or electrons. There's no two-slit experiment for electrons. You can't make a slit for electrons. Their frequency. You can't make a slit that would be anywhere near narrow enough for you to have any expectation to get a pattern, because there would be bazillions of frequencies in just the tiniest of slit would have 1,000,000 wavelengths in it, and so you'd expect 1,000,000 bars. So you should have no expectation of seeing a pattern if you could actually make slits for electrons. But you can't do it anyway because they're charged and every surface is charged, and how could you have any expectation you could send a charged object through any obstacle and its charge wouldn't be insanely relevant? Of course you can't. It's just silly. So again, they just are talking as if they have evidence, and they don't have any of this evidence. It doesn't exist. It was never done. Just like their detectors. I mean, the detectors still come up in people's videos. There was no detectors. There was no attempt to detect a photon. We have no technology that allows you to detect a photon passively.
either of a source of photons or of electrons. But
So again, it's just an overt lie. I mean, this doesn't apply to electrons. You just can't say this is the same setup for electrons. It's not anywhere near the same setup.
But now, this source its intensity is turned down so low that it emits these photons or electrons as discrete particles once every so often. So let's say once every second or once every 15 seconds.
So another experiment just can't be done. Assuring what you're trying to assure, which is that there isn't any possibility that you've sent light to both slits at the same time, that some amount of light is hitting both of those surfaces at the same time. So there's very little way you can guarantee that. I mean, poking holes in a black screen, well, yeah, that just means that when the light actually hits the hole, a whole bunch of light goes through the hole. When the light doesn't hit the hole, then the light doesn't go through the hole. So you're just saying, okay, I can slow down how many photons get out by making tiny little holes, but the holes don't work in terms of saying they won't light both sides of the experiment. Of course they could. So, it's a real subtly difficult. It's not as simple as he says, this single photon thing. So then I'll just cite the Veritasium video that illustrates just how difficult it is, and that he couldn't do the experiment the right way. He had to turn up the photodetector way up, and the excuse, and what that really forced him to do by turning the sensitivity of the photodetector way up, was to decrease the amount of time that he was allowing for these photons to be sent, that were pretending to be single photons at a time. And again, he has no instrumentation that allows for that. So it's just unrealistic. It's just a demonstration. They don't have any hard evidence that they can do single photon, first off, and that even if they have a reduced amount of light, assuming some sort of reduced number of photons, you can't detect them with a detector. It's called detecting 7 error photons a second. So obviously you can't do the experiment the way it needs to be done, which is over a long period of time. And we only have fables about those experiments. So apparently sometime in the 1800s some guy did it in France, but there's no remaining evidence of it. It's never been repeated. There's just nothing to verify this at all.
Now, the apparatus also has, a long way from the source, it has a screen with 2 slits in it. And then a long way from this screen, there's a backstop along which we place a detector at some point on the screen, which we'll measure by this variable x.
Right, so this is exactly the Feynman diagram, except you took out the little aperture that they use to have some assurance that they're only allowing light that's going fairly straight through the experiment, so to speak. But you can't do that, of course.
And so what we are interested in, let's say we are doing the experiment with electrons. So what we are interested in is what's the probability that this electron is detected at a point x on this back screen. So now we'll first do this experiment where we block one.
So again, it just never happened, never was done. It doesn't exist as an experiment. You can't do it with electrons. So again, he's citing as if the electron experiment was done like this, and it was never done like this.
One of the slits. So if we block slit number 2, then the probability we see.
Alright, so he's already drawn the big fake, phony, idiotic part of it, right? I mean, it's idiotic. The physics are idiotic. He should know they're idiotic. He should know he's not doing it right. It should be an obvious and glaring error. He should be able to catch his own gigantic and huge mistake. So this is in the context of Feynman did this in the 60s. Here we are at 2020. Let's say this video was made by him, 2015 or something. He's had more than 50 years to find the obvious and glaring mistake in this logic, and they didn't fix it. They didn't see it. They don't know about it. They can't figure it out. They haven't figured it out. I mean, it's just such an obvious mistake. So the idea is you have your slits. You could just use one and illustrate this whole thing and get it over with. But anyway, and he just drew a pattern where he had one pattern going like this and one slit doing this, right? It doesn't do that. The whole point is that's the whole point of having a great distance between the source and the slits, is to reduce the possibility of light doing anything like this. So none of that is happening. That's not what the experiment's doing. The experiment isn't sending light this way and that way. The whole point of the experiment is it's sending it dead straight, okay? That everything's been straightened, okay? And so the light's going through very straight through the slits. And that on the fringes here, you're saying, yes, there's some diffraction, okay? So there's some spreading here. These are your fringes. But the separation here is less than a millimeter. The separation here on the screen, right? The fringes are spreading. The main light isn't spreading. So the center of these two humps will be 1 millimeter. That won't change any. The centers won't change any. The center won't change any. So if you're going to draw this fairly, what you draw is you say, well, with one slit open, I get this. With the other slit open, right? So I open slit A, this is what I get, right? Now I close slit A and I open slit B. This is what I get. Okay, that's slit B open. That's what really is happening, right? This is inches here. You're measuring in inches here. You're measuring in millimeters here. All right, and this, so it's just idiotic to think that you would be able to see the difference between what this one's producing and this one's producing when there's less than a half millimeter of separation between those two. I mean, it's a tiny distance of separation. You're going to get two patterns that are going to be so close to each other you'd never be able to see that they're two different patterns. They're so close. That's just undeniable physics. The two patterns don't show up over here and over here. There's not A over here and the B pattern's over here. The B slit shines the light over there and the A shines the light over here. No, they both shine it off this center, okay, and they both will create fringes, okay, this way in pretty much exactly the same location. So if I did single slit from here, okay, with this one closed, I should have drawn it the other way, right? Yeah. Close this and just have a single slit open, all right, I'd get a pattern, right? We know the single slit makes the pattern. And if I close this slit and open this slit, I'd get the same exact pattern. I mean, it would be just such a tiny amount of distance off. You wouldn't be able, if I just flashed one and then flashed the other, you'd say I flashed the same pattern, that I didn't change anything. Because this change, the distance change here is so tiny. It's such a glaring misrepresentation to sit there and draw those two in uneven space, because both of them will create hump here, hump here, hump here. A pattern puts one here. B pattern, B slit, puts one right here. They both are putting it in exactly the same place. So wrong. Just so glaringly wrong. Nobody cares. Nobody. Oh, screw that. You're just being a party pooper. It's just so bad. And they, it's systemic. They're doing it all wrong all over the place. And you people are just saying, okay, I don't care. Facts? Yeah, who needs them?
The electron at point X varies according to this curve P1 of X, which has this behavior because when it's what we'd expect, because when the electron goes through slit 1, it sort of it gets scattered by the slit, and so it goes in some direction. But
so now you're starting to talk sense, right? Where it gets scattered by the slit. Well, what part of the slit is scattering it? Oh, the surface would be doing that, wouldn't it? Yeah, it would. Oh, it's hilarious. And obviously there's two surfaces, so there's 2 points where it's scattered from. Yes. Oh, it's just amazingly bad.
It's most likely to go along the straight line path, and so you get a...
So the straight line drawn to these silly proportions, right? When we know if you really could draw this the way it's really done, right? If I had a 10-meter blackboard and I could draw it to actual proportions, you'd get it, because it'd be these little tiny slits that you couldn't even see over here. And then you'd be saying, well, why has the pattern got all these funny angles in it? Because the light's not doing that, it's going straight. So why would it do that? It's not going at those funny angles. The source isn't, the source is saying there's 1 millimeter in front of me. Why would it be going like this, right? Why would the source, to get to a 1 millimeter slit, why would the line be going that way to get to the 1 millimeter, right? If I need to go to 1 millimeter, I don't need to go this way. I'm not going to be going that way. I'm going to be going frickin' as straight can be. So it's just, it's a joke.
This peak here, and then the probability drops off as you go further out.
So again, there's no way these two lines would have any separation you could see at the target. At the target 10 meters away, you're never going to see that half a millimeter difference in where those two centers would be. So the center of this mountain and the center of this mountain are going to be a half a millimeter different. You'd never be able to see that difference. You go right up to the board and you say, gee, it's so tiny a difference. Compared to the full size of the pattern's this big. You're not going to see little tiny 1 millimeter difference. You're just not, there's no way to see it. It's silly.
There's a similar such curve, P2 of X, when we have only slit 2 open and slit 1 is closed. Now, what happens when we open both slits? Well, what we'd expect to see, since the electron can go either through slit 1 or through slit 2, is the sum of these two curves.
Right, and that's what you do see. So that's the ironic, funny part. When you do the math, that's exactly, it's the sum of the two. It's the vector from one and the vector from other, and you add them up and you'll get the result. So I mean, just because he's put these in two insanely silly locations, where he's almost implying that the fringes are being created by their eccentrically different positions in space, and somehow that's creating the fringes. When no, what's creating the fringes is the fact is that the light on the sides is scattering from both sources. That's exactly the vectors you draw when you do the math. So the vectors are showing you exactly what you're doing, which is going from one surface from another surface and combining the two and saying what's the effect of two sources. And the two sources can send pieces of a photon, and that's the simple explanation. The photon is broken going next to the surface. Pieces still go to the wall, and where the pieces can be put back in phase, you have a photon. And where the pieces aren't put back in phase, you don't have a photon. And that's the simple explanation.
So something like this. What we actually observe is this interference pattern.
Alright, so again, this is just silly because both of these center humps should be right here in this center. Both of them, if I did the single slit, open one slit, I get a pattern. If I open another slit, I get a pattern. I don't get a clump like this in the first place, so that's part's nonsense. And again, those two clumps will be right on top of each other, and you could argue I don't get any pattern, I just get one big clump. So the comparison is one slit open, I get a big clump. You know, the other slit open, I get a big clump. Both slits open, now I get you know, a change in the pattern. And really all you're really going to do is you're going to see light you didn't see before. The simple point is with one slit open, you only have two sources of parts. With two slits open, you have four sources of parts. And that means you have to square how many places there are where you're going to have where it's possible to reconstruct a photon. So you're going to get 4 times as much light. You're going to have 4 times as many successful reconstructions. When you double the number of slits, you get 4 of sources. You quadruple the number of successful reconstructions.
So let me call this P12 of x. This was P1 of x, and that's P2 of x.
So this, like I said, one slit is sending pieces, the other set is sending pieces, and you just sort of understand that obviously if I put those two on top of each other, I'm going to be having, like I said, it's 4 sources worth of pieces.
The mystery is, how could it possibly be that when both slits are open, we got this strange interference pattern?
So we know we got the strange interference pattern when one slit is open. We know the pattern is there. Alright, and he's just being deceptive in the sense that he's not pointing out that what this really means is that there's distances between the point sources. And that's what's going to be in the math, is the distance. And it's how many wavelengths fit inside that distance. So obviously, when you have just a single slit, you only have one little distance. When you have a double slit, right, now you have this outside distance, which is much larger, right? And so that provides path lengths that are much longer, and therefore you know, more opportunity to make photons that have a different phase, more phase variance, which means more potential to fix the broken photons.
Let me put it to you more succinctly. So let's look at a particular point on this screen. Let's say we look at this particular point on the screen. So this is a point where there was a substantial chance that.
So again, if they understood anything about the basic geometry of the experiment, you would know that with either slit, this point's going to be light or dark. this location is a location that both of them are going to show it at being exactly the same intensity at this location, because these two humps are going to be right on top of each other. So this location is going to have a common intensity. And he's arguing that somehow he knows that that's really the dark spot here. That's really, when you put the two slits together, that's going to be a dark. And it's not the truth. Nothing ever gets darker. The lights get 4 times brighter. Nothing gets darker. All you can do is, because you're adding more sources, you make the photons, the number reconstructed, 4 times brighter. So the thing that was next to a dark looks like the dark got darker, but the fact is the light got lighter.
That the electron got here when only slit 1 was open, there was a substantial chance that the electron was detected at this particular point. So now we would say to ourselves, if the electron went through slit 1, how could it possibly matter to it whether slit 2 was open or not? And if it did not matter to it, how could it be that the probability of detection of that electron went down from a substantial value to being very close to 0?
Right. So he says it happens, that you shine the flashlight and somehow you shine the anti-flashlight. You put more light on and you make some of the light disappear. There's no evidence, there's no experiment, there's nothing. It doesn't actually happen. All that you can do is there's a dark spot, and there's a spot that has a certain intensity. And by opening another slit, what I can do is I can make the bright spots next to this less than bright spot, I can make them 4 times brighter. But I can't make this any darker. That doesn't happen. No evidence, no experiment shows it. Doesn't happen. It's just a silly story. Again, the whole thing is just remaking photons, and it's proven with the film. The polarizing film proves the point, because they always thought, I even thought, I bought the silly story, okay, that the polarization is blocking the light. The light isn't going through the film, okay, it's blocking half the light. And the truth is, it didn't block the light, it just broke half the light. Half the photons now have had their polarization disrupted. I mean, their phase disrupted, because all the polarizing film is, it's worth drawing it. I mean, I have been over it, but it's so simple an explanation. It's so obviously the right answer. Obviously. Hopefully, I'm really not paying enough attention to the size of the screen. Got to keep everything in this little box. The polarizing film. So we have this idea, people, okay, you have a film going this way, or you can have the film going this way, and this blocks 50%, this blocks 50%, and then you end up with 0%. Okay, and the fact is nothing's getting blocked. All the polarizing film is doing is it has lines on it, and if you were to look at on edge, okay, all you're really doing is changing it from 1 to 2 thicknesses. So you have 2 films on top of each other. So the first film, this layer, creates 1x phase shift. That is, you've shifted the frequency from this to this. Okay, and or in your wave example, you've gone from this to this. You've changed the phase. And then when you go through this second layer, you change it again. And so the second layer essentially puts it back on phase. That is, if you had one wave going this way, then the one that goes through the second layer, it will be this wave. So this wave is the one that went through the second layer. This is the hump that went through the first layer. If those two went through the film at exactly the same time, they're actually going to be put in order. One of them is going to be delayed twice as much as the other one's going to be. And so that's all you're really doing to the photon. So some of the photons that come in, depending on which way their polarization is, right, have more of their bits go through the 2x film or the 1x. And based on that, their polarization is broken. So the film lets half the light through, where its polarization stays consistent because it's able to get through these gaps. It goes through straight this way and goes right through. Just all the pieces go through the same filter, so they're not broken. They're not disrupted, because every piece of the frequency goes through the same piece of filter, right? Either a lump or a 1x lump or a 2x lump. They go through the same filter. The ones that go through the same pieces, they are all stay in phase. The photons where one piece goes through this piece and one piece goes through that piece, they're the ones that now have their phase broken. So now they're a photon that looks like this, perhaps, instead of a photon that looks like, this. Well, 4. So this one has the right frequency. This one has obviously the wrong frequency to be seen. It can't be deciphered by our eye or by any of our detectors, because our detectors require the frequency to be consistent. Just like your radio receiver requires the signal from the antenna to be consistent. The antenna can't keep changing the megahertz unless it's an FM signal, and then there's a whole explanation for that, because it's a range it's detecting. But anyway, generally speaking, the consistency of the frequency will decide whether the signal is receivable or not. And the same is true for photons. If you break the consistency of the signal, you break the photon. And the point is I can put through a second filter that'll fix this broken one. This broken one will do exactly the opposite of what it did the first time and end up putting the photon back together. And then obviously, if I'm sending a bunch of broken pieces, I can take a piece from the A photon, combine it with a B photon, and even combine it with a C photon that was going through at the same time, and I can put those back in order. So I can take the pieces and reconstruct them. And the proof of this experiment is the fact that you can put a third filter in and get more light out. Obviously, if you're putting a third filter in and getting more light out, it must mean there are pieces, there's still energy you can recapture. So the energy made it through the filter. It's just broken, and now you put it back together. That's the right answer. That's the fact. If there was aliens out there, that's what they know. Okay? And this silly story they're telling is just that. And it's a silly story. It's obviously silly. It's obviously a story. It's not well evidenced. And you really just... It's just sad that you're just too stupid and too ignorant and too Trumpy, to figure out you're being gamed and duped.
This is really in a nutshell, this encapsulates the mystery of...
It encapsulates fake news, fake science, bullshit, horseshit, nonsense, rubbish, unevidenced storytelling. It's just completely opposite of the truth. Donald Trump, I'm a billionaire. I earned it, inherited it, lost most of it. I mean, the worst kind of example of a person who should be respected as a success of any kind, or competent in any way. How incompetent do you have to be to lose millions of dollars you were handed? I mean, the incompetence is grotesque. And you're saying, basically, I want to invest in that man. And all you're investing is look, it's one subject, immigration. That's it. It's always been one subject. People can't see past it. And the rest of it's just typical Republican crap of the religious kooks. They'll vote for anybody who just plays lip service to Jeebus. And obviously Trump just his lip service is so hilariously even bad. The upside down Bible thing. I mean, you're just stunned. People can't be this foolish. But they can be. And they are. And it's sad to live with them. It's like living with people that smell really bad. Ew. It just sucks. So, I have pointed out that I hate this planet, and for very good reason.
Atomic particles. How could they possibly behave? How could nature possibly?
Right, it doesn't. So again, you're just making up stories and you're forcing the evidence to match what you want it to say, and it's that simple. It doesn't do any of this wacky wooey crap. You're just living in a silly fable. It's a silly little three bear story. It's a three bear world. It's a cartoon. This isn't the Flintstones. You don't stick your feet through the bottom of the car. I mean, that's how bad his drawing was, frankly. His drawing was as unrealistic as me just telling you that, yeah, you can just stick your feet through the bottom of the car and push yourself along. And,
What could nature possibly be doing behind the scenes that makes atomic particles behave in this way?
Well, what are you people doing behind the scenes? You're obviously not doing any experiments. So, and you're obviously not in any way critically inspecting the stories you're telling each other. It's pitiful. And this is their cornerstone. This is the experiment that they've built this whole silly pile of shit on. And it's so simple and so obviously been misdescribed.
This mystery is illustrated by this quote from the great physicist Richard Feynman.
Right. So, obviously, this guy, this is, obviously this might have been one of his instructors or something or whatever. But he's just quoting him essentially and through the whole thing. And he's drawn the wrong diagram showing the wrong facts.
Who once said, "I can safely say that no one understands quantum mechanics."
Right, because it's a silly story, preposterous nonsense. It doesn't make any sense. It doesn't answer any questions. It's just a pile of wooey gremlin rubbish. Gremlin's done it. That's all it is. And people are, again, who's worse? These people saying this stupid shit, and then the idiots eating it up and believing it. Ugh. What's worse? Trump or the Trumpers? Yuck. All right. So, till the next time, such. I have lived too long. Just, oof. Yeah. Yeah.